Thank you, Yvette. The next speaker is Dr. Troy Rowan. Troy is an assistant professor at the University of Tennessee's Genomics Center for the Advancement of Agriculture. His research uses genomics to understand and predict complex traits in beef cattle with a focus on improving local adaptation, exploiting heterosis, and improving forage-based sustainability. Troy also serves as an extension beef cattle specialist, educating producers and industry partners on genetics and sustainability in Tennessee and nationwide. Thank you, Troy.
All right, thanks, Rob, for the introduction there, and Yvette did a really good job underlining sort of the overarching things that we think about from a genetics perspective. When we go out and try and improve any trait, it's become much more easy with the inclusion of genomics to integrate new traits into genetic evaluations and get those tools into farmers' hands faster. And that's something that is absolutely going to be true as we forge forward in trying to breed more methane efficient cattle. And so I want to give a little bit of specific context in this presentation about challenges that we have on the beef side of things. Beef cattle, of course, have a much bigger population footprint across the world, here in the United States by a long shot compared with dairy cattle. But there's a set of unique challenges that we have in capturing those phenotypes that Yvette talked about that are really the foundation for doing genetic improvement. Phenotyping these populations of beef cattle comes with a number of the same challenges as delivering feed additives or other management interventions. So I want to go through a few of those, if I hit the right button there. So I guess here's sort of the state of things in what we know right now. Methane is heritable. The estimates are somewhere between 0.2 and 0.4 heritability. That is good meat on the bone for us to make genetic change on a trait. This is similar to a lot of our production traits, growth traits, milk production in our beef cows as well that we measure and have genetic predictions for, very much on par with those values. We're also starting to expand our knowledge of how the rumen microbiome has a genetic component to it as well, and how that information might help us make better predictions of an animal's methane potential. And so trying to understand the interplay between host animal genetics and the rumen microbiome is something that is really rapidly expanding and will certainly be a big part of what we work on into the future as we do these predictions. But as Yvette also said, phenotyping remains our major bottleneck, and this is the chief challenge, I think, for us in the beef industry. Capturing these phenotypes on animals that are out grazing in extensive situations, which is where we want to measure them, right? We don't want to put cows in a different scenario than where they're actually going to be performing all of the things that they do, right? Eating grass, turning it into milk, and ultimately turning that into weaned calf and eventually beef, right? So we want to do this phenotyping in the place that's the most contextually close to where that animal is going to operate. And so that is a huge, huge challenge for us in figuring out how we collect these phenotypes in extensive production situations for beef cattle. And then finally, the economic signals are a little bit tricky. Yvette showed a desired gains approach. Usually when we include new traits in our selection objective, we want to be able to attach a concrete economic value to them. And right now, methane is a challenging trait for us to go out and tell a producer to include in their breeding objective, right? So once these initiatives leave, what keeps these things in our breeding objectives, what keeps these phenotypes rolling into genetic evaluations, I think is something that we absolutely need to answer, and something that I'll talk about here in just a second. So really, as we think about phenotyping cattle in extensive situations, in grazing situations, we've deployed these green feed pasture systems. Challenges here, of course, are that we're much lower throughput than we'd like to be. We're not able to run these animals. They're not hitting that green feed as consistently as they would be if we had them in a dry lot or in a dairy. We've also started to deploy sniffers. This one in particular has a mineral supplement in there, something that a cow is going to go get every day. Capturing those phenotypes, again, whether they're something that's a little bit more gold standard or something that's a really good indicator, we hope, of methane emission, but both able to be deployed with solar panels, cellular connectivity out in these extensive situations so that we're capturing phenotypes on cows in their working clothes, as we'd like to say. And also, I think that in the future, as we start to consider how these things fit together in genetic evaluations, using true gold standard measures like these portable accumulation chambers that our colleagues in New Zealand have been working with for a while now, integrating those with other indicators in big genetic evaluations, using these things as correlated traits is going to be very, very important for us as we attempt to implement breeding programs. So the one other big challenge that I would draw your attention to with measuring these phenotypes and predicting them in our populations is that even in the United States alone, not to mention all of the international perspectives we heard about this morning, there's a huge amount of environmental variability, and we would suspect a fair amount of what we call genome or genetic by environment interactions in these traits. These cattle that graze in Tennessee, where I'm from, are grazing very different forage than cattle in West Texas, where my wife is from, and very different environment from where I grew up in Iowa, right? All these different production environments, we have different forages, we have different stressors that affect these animals at every step in their productive life. So how are we able to integrate this information into our models, understanding that different forage types, different environmental stressors are going to have a big impact on methane emission, and some animals may be more or less predisposed to deal with that in these really extensive and harsh environments. And the final thing I'll mention here is that we have this challenge of genetic antagonisms. And this is not true just in the beef industry, but really across all of our livestock, where sometimes to give something, we have to take something away. And this is very true for our cow-calf producers, the folks who graze these extensive situations, and the demands that they're getting upstream in the supply chain, where we want bigger carcasses, more weight, right? More days on feed, bigger slaughter weights for our animals. But we also know that our smaller, more efficient cows are able to more efficiently convert their forage resources into beef, and the same thing absolutely goes for methane. There's a little bit of a discrepancy here. We have to deal with this in how we model these things in our selection indexes to make sure that we're truly capturing the optimum values for all of these traits from the animal's birth all the way through harvest. And so the challenges and opportunities that I see for our industry, for the beef industry and methane mitigation, is a big challenge in modeling methane in our selection indexes. The good thing here is that it has a favorable correlation with forage-based intake. Our challenge, and the thing that I think is a real opportunity, while a producer, once these big initiatives maybe start to fade, we've captured these large reference populations, we have to have a continual intake of phenotypes. Producers may not feel the economic impact of capturing a methane phenotype, but they absolutely do in understanding an animal's efficiency on forage. So I think as we communicate with producers, this is a big plus for increasing the methane efficiency of our animals, is that we're also able to make these animals more efficient utilizers of forage. And then lots of new indicators coming online. Yvette did a nice job underlining those that are going to help us collect these phenotypes continually over time. And then finally, this is a segmented industry. We're not integrated like our counterparts in poultry or in swine, but I think that targeted investments in sustainability-focused supply chains are going to be very important for us, right? Helping producers at the cow-calf level feel the pull-through of making breeding decisions that impact the ultimate sustainability of their product. So with that, I think that's all I have. Appreciate being on the panel and look forward to a good conversation, Rob. Thanks.